concept of prestressed concrete. Prestressed concrete is a system into which internal stresses are deliberately induced without any form of external loads to improve its performance. The internal stresses induced in the concrete structure is used to counteract the stresses coming from the external load applications. As mentioned before, prestressing is the application of an initial load on the concrete structure so that the structure is able to counteract or withstand the stresses coming due to the service loads. The concept can be clearly understood by the example of the barrel. A barrel used in the olden periods to transport liquids and grains are tightly bound by metal bands as shown in figure 1. These metal bands are fitted so tightly that it creates a hook compression around the barrel. When this barrel is filled with liquid, it exerts hook tensions. Similarly, effective internal stresses are induced into the concrete by means of tension steel bars before the concrete structure is subjected to any service loads. The stress counteracts with the external stresses. Principle of prestressed concrete. It involves the application of forces tending to bend and compress a concrete element in order to counteract bending which results from loading. The force applied is the tensioning or stretching of the steel component, which usually in the form of high tensile strands, wires or bars. There are two types of prestressed concrete, which is pre-tension concrete or post-tension concrete. Pre-tension concrete is most often used in the factory situations. The tendons are tensioned against some abutments before the concrete is placed, for post-tension concrete is usually used at site, and the tendons are tensioned after the concrete has hardened. There are two types of prestressed concrete, which is pre-tension concrete and post-tension concrete. In the pre-tensioning method, the stress is induced by initially tensioning the steel tendons. These are wires or strands that are tensioned between the end anchorages. After this tensioning process, the concrete casting is performed. Once the cast concrete has hardened sufficiently, the end anchorages arranged are released. This releasing transfers the prestress force to the concrete. The bond between the concrete and the steel tendons facilitates this stress transfer. For the post-tension, the steel is prestressed only after the beam is cast, cured, and attains strength to take the prestress. Within the sheeting, the concrete is cast. For the passage of the steel cables, ducts are formed in the concrete. Once the cast concrete hardens completely, the tendons are tensioned. One end of the tendon is anchored and other end is tensioned. In some cases, the tensioning can be performed from either side and anchored subsequently. Once the prestressing is complete, there is space between the tendons and the duct. This leads to bonded construction and unbonded constructions.
Prestressed construction work in pre-tensioning. Okay, number one is before this casting of the concrete, and number two is placing the high tensile steel tendon in which the concrete to be cast. And the example is foundation pass, railway sleeper, floor slab, and beam. Next is pre-stressed construction work in post-tensioning. So, number one is the process of introducing compressive force to the concrete after the concrete is casted. And number two, introduce compressive force to the concrete and it achieves the required pre-stress strength. And the example is roads, bridge, railway, and tunnels. And last one is pre-stress construction work. So, Tracing tendons is generally found in high tensile steel cable or rods. So it used to provide a clamping load which produce a compressive stress that balance the tensile stress the concrete compression member. So the procedure is setting up the mold and the production process. So it will be shown in the video. Enjoy the video.
Why precast concrete is preferred compared to conventional in situ construction method? The first one is because of the quality control. Precast concrete is made poured and cured in a factory. Ideal conditions and exact measurements can be maintained throughout the process. All concrete must pass strict testing before assembly on site. The second one is because the precast concrete is labor efficiency. Precast is much more labor efficient. Because work is done in a factory, the effort is maximized through technology and machinery that simply is not available on site. The third one is because precast concrete is more economic. Precast is factory made and have standardized forms, thus having fixed pricing, which enable us to accurately budgeting the construction costs and avoid going over budget. The fourth one is it can promote sustainability. Because of the precision of precast concrete, material waste will be minimized. The fifth one is because the precast concrete have no on-site formwork. The formwork required for on-site concrete pouring is both time and space intensive. By eliminating logistical concerns, scheduling becomes easier, thus ensuring no unexpected costs.
The, the next reason why precast concrete is preferred compared to conventional in situ construction method is better workmanship. At a practical level, quality is concerned with workmanship. The survey of some precast and in situ concrete houses support that the fact that the precast concrete give better quality in terms of strength, durability, stability, and more reliable than cast in situ concrete. The next reason is cost reduction. The literature review showed that precast concrete construction give the least cost per unit than in situ concrete construction. The research findings also indicate that the professional architects and contractor perceive that to be the case. This, they said precast concrete construction is cheaper than in situ concrete construction because there is no formwork to be erected and stripped. The last reason why precast concrete is preferred compared to in situ construction is time saver. The research also indicate that precast concrete construction gives shorter total construction time on a housing project than in situ concrete construction. This research finding support the author of the literature review who say that precast construction is faster than in situ concrete construction because elements are assembled on site without any waiting period for concrete to cure.
Precast concrete able to contribute towards reducing global warming issues. Concrete production is responsible for 8% of global greenhouse gas emissions, and as populations continue to grow, demand for concrete continues to rise. The production of concrete is also a major contributor to local air pollution. A 2009 report commissioned by the WCSD estimated that 1,800 kilograms of carbon dioxide are released during the production of 1 ton of cement on a global average basis. Because concrete can lead to 10% carbon reduction for 1 cubic meter concrete, according to article from Dong in 2015. The production of precast concrete able to track carbon emission because has higher uptake at 9.6%. In Kuwait International Airport, they are applying the precast concrete elements. The precast and average size of precast element is about 81 meters squared. Carbon dioxide emission saved by the adaptive mold equals the equivalence of a full-grown forest for 4 years, covering the 37.7 kilometers squared area of Kuwait International Airport. This shown that the precast concrete elements are really helps reducing the carbon dioxide emissions. You can find out about more the Kuwait International Airport from the QR code here. From the QR code, you can see the precast concrete elements in the Kiat to Terminal 2 Kuwait International Airport. The video will show you the manufacture of heavyweight precast concrete elements which hold the roof of the Terminal 2 building.